In this video, I'm going to talk about squeeze theorem for limits. But before I do so, let me go ahead and talk about something else. Let's consider two functions, f of x and g of x, okay? F of x and g of x. And we make the assumption that f of x is always less than or equal to g of x in some neighborhood of, let's say, some point A. When I say in some neighborhood, some small neighborhood around A, f of x is always less than or equal to g of x, but excluding the point A. So exclude point A. So some interval around A where this statement or this relation holds true, possibly except for A. That's why I'm saying exclude A. If that is the case, by the way, we could say the following. Limit x approaches A, f of x is less than equal to limit x approaches A, g of x. Now let me go ahead and take this idea and compare three functions. So let's consider three functions, f of x, g of x, and h of x. So f of x, g of x, and h of x. The relation among these three functions is this. F of x is always less than or equal to g of x, and g of x is always less than or equal to h of x, again for some neighborhood of A, for some interval or some smaller area containing the point A, possibly except for A, meaning that we do not say that this relation holds true for the point A necessarily, but all the points surrounding A, it holds true. Okay? Now, if that is the case, by the way, this is what happens. Limit, okay, x approaches A, f of x is equal to limit x approaches A, h of x, look, f of x and h of x. So we are sandwiching g of x in between. If both of these limits exist, and let's say that value is L. So we are making a couple of assumptions here. One is this relation holds in some neighborhood containing A, except for A possibly, and also the limit f of x as x approaches A and limit h of x as x approaches A is L. If that is the case, by the way, then it must be the case that limit x approaches A, g of x, the one that's sandwiched between these two functions, g of x is equal to also L. This is called squeeze theorem, sandwich theorem, or maybe it has some other names, but in the US we call it squeeze theorem. Now, the easiest example of squeeze theorem is using this function. F of x is equal to x squared times cosine of 1 over x. We need to find the limit of this function as x approaches 0, or equivalently, limit x approaches 0, x squared cosine of 1 over x. And you can apply the multiplication rule for limit. That's going to give you limit x approaches 0, x squared, right, times limit x approaches 0, cosine of 1 over x, cosine of 1 over x. Now, this is kind of not taking us anywhere. Limit cosine of 1 over x, we don't know what it is, and this goes to 0 or approaches 0. So this is kind of not so good situation to deal with. However, we could use the squeeze theorem here. Let's look at cosine of 1 over x. We know that cosine values are bounded below by -1 and bounded above by 1. So that means -1 is less than equal to cosine of 1 over x is less than equal to 1, regardless of the value of x, right? Cosine and sine values are between 0 and between -1 and 1. Now, what I'm going to do, I'm going to take this inequality and I'm going to multiply it by x squared. X squared is always positive or 0, so we are okay here. So it's going to be what? Negative x square is less than equal to x square times cosine of 1 over x is less than equal to x square. Now I'm going to apply limit to all three parts of this inequality. So limit x approaches 0, negative x square is less than equal to limit x approaches 0, x square times cosine of 1 over x is less than equal to limit x approaches 0, x squared. Now here is the interesting part, or the squeeze theorem part comes into play. As x goes to 0, negative x square also goes to 0. As x goes to 0, positive x square also goes to 0. Since this function is contained between this one and this one, right? And the limits of the left function and the right function, both of them go to 0. So the intermediate or the middle function, it has no choice but to converge to 0. So the limit of this function, limit x square, limit as x approaches 0, x square cosine of 1 over x is nothing but 0. I hope that this discussion was helpful. Thank you very much.